All right, we just have a couple more things for this lesson. The next one is calorimetry, and metry means to measure. Calor has to do with the heat energy. So this is the idea where if you use something called a calorimeter, this is something that traps energy in, then we can do an exchange of energy from one thing to something different, and we can assume that all of the energy lost by one thing is going to equal the energy gained by something else. So sometimes it's easier to measure the temperature change and just that we can calculate the energy better about one thing, and then we can set it equal to the other one, and we can use that to do some calculations. So for example, if we were in school, we would do a lab where I give you a metal and I ask you to identify it. And what you would do is put it into the freezer that I have, and you would look at the temperature of the freezer and you would wait for it to get that cold. So we would know the starting temperature of the metal because it's the same as the freezer. And then what you would do is to drop it into water, and the water is going to be warmer than the metal, and so the water would lose energy to the metal. We would put it in a styrofoam cup and seal it off to try to keep all the energy in. And so what we can do is measure information about the water and then assume that all of the energy from the water went into the metal. And so we can set them equal like this, and we can plug in MCAT. All of these variables would be about the water. So the mass of the water, which we would probably measure the volume, because for water, it's the density is 1 gram per milliliter. So however many milliliters you have, that's how many grams you have. We know the specific heat of water is 4.18 joules per gram degree Celsius. And we could easily measure the temperature change. So we would put a thermometer in and we would find out the difference in temperature. So we would find the initial temperature, drop the metal in, and then see, once the temperature stops changing, see what the new temperature is. For the metal side, so all of this over here, we can easily find the mass of the metal by putting it on a balance. We know the initial temperature because it was the same as the freezer, and then the final temperature of the metal will be the same as the water. So the thing about energy exchange is that they will meet somewhere in the middle, not necessarily halfway in the middle, but they're going to meet at the same temperature eventually once the temperature stops changing. So the final temperature of the water will also be the final temperature of the metal. So you see that we know all the variables about the metal except for that C, the specific heat, and specific heat can identify a pure substance. So for example, we know that water specific heat is 4.18 joules per gram degree Celsius. So we basically can figure out all of these variables except the C on the metal side, and so we can calculate that, and then we can use a reference table to look at specific heats to identify what the metal is. And that's a really common lab in AP Chemistry, and so you might see questions about that on the AP exam. And our very last thing for today is talking about breaking bonds versus forming bonds. You're going to see this a lot throughout the year. So if you can go ahead and get it into your head that when you break a bond, it requires energy, and when you form a bond, you get energy from it. Now, sometimes there's a lot of other things happening in a reaction, so it's not whether or not a reaction happens is not purely based on the heat of the reaction. There's other things like entropy, and we'll get into those later. But for now, I just want you to remember that if you're breaking a bond, so if you take a molecule and you break that bond, that is going to require energy. That's going to be endothermic. And if you're forming a bond, you're going to get energy. And it kind of makes sense because bonds are going to form to become more stable. So once something forms a bond, it's at a very low energy. And so to make it get out of that low energy state, you're going to have to put energy into it. And then when you form a bond, forming a bond makes things more stable. That's why they form bonds. And so if they're at a lower energy once you form the new bond, then that means they lost some of the high energy they had to start with, and the energy has to go somewhere. Remember, the law of conservation of energy says you can't create or destroy energy. So if you start at a high energy, form a bond that's at a lower energy, that new energy has to go somewhere. And so that's why it's exothermic, is that it's going to leave it. So go ahead and try to, if you can remember that breaking is endo, forming is exo, that's going to help you throughout this class. And that's it for section 6.2.